On the one hand, this problem is very easy. On the other hand, this problem is pretty complex. Because what this problem is demanding is that you understand the relationship between y equals f of x. F of x is an equation. F of x is an expression. And it is expressed as algebraically, or it is expressed as a graph. So this is the graph of f of x. I'm just highlighting it right here so that you can see it. Here's our graph of f of x. One of the things that we know about all functions is that, well, let's just take another step here. If I say something is greater than or equal to 0, that means if here's a graph, and here is y equals 0, if f of x is greater than 0, it's going to be up here, greater than 0. And f of x is less than 0, it's going to be down here, below the x-axis. So in this particular problem, really all I'm asked to do is say, for what values of x, when I'm solving inequalities, that's what I'm asking, say, for what values of x will this expression be true? So I'm going to start by dividing my graph into intervals, because the only places that I can switch from positive to negative or negative to positive, the only places are either where I'm crossing the x-axis, so I have a 0, or if I have an asymptote, because it's not uncommon for a graph to say go like that and follow the asymptote, but then on the other side of the asymptote to jump and become positive. So it's an asymptote or a 0 are the only spots that I can make those changes. So let's look at the graph. Well, I see that I have a vertical asymptote right here. So VA at -1, x equals -1. And then my graph crosses right there at the point 1, 0. Then I have another vertical asymptote right here. That is at x is equal to 2. And then I have another 0 right there at the point 3, 0. So my graph has been divided into some intervals. One interval goes all the way to here. Goes from negative infinity to -1. And then another interval, let's make that 0, let's make it a nice block right there. Another interval goes from -1 to 1. So I have another interval from -1 to 1. And then I have another interval right in here. I'll make a little arrow that goes from 1 to 2. So that one, this covered that one there, and now I'm covering that one there. I have another interval that goes from 2, so I have a 0 there at 3. It goes from 2 to 3, and then I have a final interval, it's covering this right there, that goes from 3 to infinity. So I'm looking at my graph, which is in red right there, and I'm going to mark in green now. I'm going to mark in green where in my graph does it solve this inequality. Where in my graph are my y values greater than 0? Well, they are greater than 0 for this whole piece right here. They're not greater than 0 for the next interval. They are greater than 0 from 1 to 2. They flip back down being negative, and then again they're greater than 0 here from 3 going onward. So the green now identifies the intervals where this is true. So the answer to this problem is negative infinity to negative 1, union 1 to 2, union 3 to 0. Those are the intervals for which f of x is greater than 0. Now, it does say greater than or equal to 0. So where I have a 0 right there at 1 and right there at 3, those are included. So those are brackets. 1 and 3 are brackets because they are included. So this is, in a sense, it's a no-work problem. You just need to look and see, where do I have vertical asymptotes? They're marked. Where do I have zeros? Where the function crosses the x-axis. And then I've broken my whole graph up into different intervals, and I just look for the ones that solve this inequality. And that's the answer to the problem. No having to figure out what's the equation, no doing any algebra, just straight up looking at the graph.